Hello, it's me, Oscar from Marijuana Garden.
So let's dive in and talk about petabit internet speed. It's honestly pretty mind-blowing to think about how fast data can travel these days. Based on verification against credible scientific publications and technology news sources, the information is largely truthful and accurate. 2 petabits per second is confirmed. 1,808 kilometers is confirmed. Next generation 19-core optical fiber is correct. Japan's National Institute of Information and Communications Technology is the lead research organization. While the exact size fluctuates, the entire Netflix catalog is estimated to be in the range of petabytes. 1.02 petabits per second is roughly equivalent to 127.5 petabytes per second. This research absolutely pushes the boundaries of what's possible for future backbone networks. The potential applications mentioned are valid long-term goals: next-gen internet, 6G, AI data transfer, cloud computing. This is a laboratory demonstration using highly specialized, experimental technology. It's not something deployable in commercial networks today. Wavelength division, multiplexing is the core technology enabling such high speeds. The NICT experiment used a staggering 801 parallel wavelength channels across the C and L bands to achieve the total 1.02 petabits per second. Signals were encoded using complex modulation formats. Sophisticated digital signal processing algorithms were essential at both ends. Scene 2. Importance of distance. This wasn't a short loop. 1,808 kilometers simulates realistic distances between major internet exchange points or data centers within a continent. So, standard single-core fiber is really hitting some fundamental physical limits. Multi-core fiber, or MCF, actually creates multiple lanes within just one fiber strand. The 19-core fiber used by NICT, well, it really represents a significant advancement. This is, a research breakthrough, not a product just yet. Commercial deployment is likely years, possibly even a decade or more away. Manufacturing 19-core fiber and all the required lasers, amplifiers, and receivers is, at the moment, extremely expensive. Deploying MCF would actually require overhauling the entire optical network infrastructure. And honestly, the signal processing required consumes a significant amount of power and needs very advanced electronics. So gigabit speeds are, pretty common in many developed areas these days, and 10 gigabits per second is starting to emerge as well. But just to put things in perspective, 1 petabit per second is actually 1 million times faster than 1 gigabit per second. Major internet backbone links right now usually operate in the terabit per second range. Since 1 petabit per second is equal to 1,000 terabits per second, this really represents a massive leap forward. NICT itself actually held the previous long-distance record of 1 petabit per second over shorter distances back in 2020. But with this new record, they've nearly doubled the distance for petabit transmission. The information you provided is, factually correct regarding the speed, distance, technology, and the institution involved. Using the Netflix analogy is honestly a reasonable way to illustrate the massive scale. And yeah, the potential future impacts you mentioned are valid long-term aspirations that are being driven by this kind of research. Scene 2. Final context. However, it's important to remember that this is really a groundbreaking laboratory demonstration, not something that's ready to be deployed just yet. It definitely showcases the future potential of optical communications, but there are still some pretty significant cost, manufacturing, and integration hurdles before this can actually become a reality in the networks that power our daily internet use. Still, this research is absolutely vital for building the infrastructure we'll need to handle future decades of data growth.
Mm.